So as for the fourth and final question, we're dealing with the square of the random variables. On the fourth question, we need to find out the joint density function of x squared and y squared. For the sake of convenience, we make we make two new random variables. That is, z equals x squared and y squared equals w. So we get the joint. So we get the joint density function on the textbook. This is a formula from the textbook, and we need to substitute these xi, yi with concrete terms about this question. So first we solve these two relations. We get the roots. There are four roots, each of which has square root of z and square root of w. Each of which term can be either positive or negative. So 2 multiplied by 2 equals 4. There are 4 combinations. So actually our summation has actually four terms. Each of the term is made up of 2 minor terms. So that should be 1 and xy. So the term should be like this. Note that I wrote multiply by 2. That is, if both signs of the roots are positive or both signs of the roots are negative, actually their corresponding contribution to the joint density function are identical. So because 2 negatives equals 1 positive. So I wrote multiply by 2, where these term there is a plus. Similarly, when the signs of these two roots are different, we could get that there is a negative, there is a minus sign. Remember also that the denominator, because there is an absolute sign on the denominator, so denominator should always be negative, should always be positive. There is no negative signs, so these are just positive. Okay, so after some calculation, you could find that the zw. So the second term, the corresponding second term, all cancel, leaving the first term. So the final result should be 1/4 square root of z multiplied by w. We can verify that we do the integration of its entire space, and we could get 1. So we could